Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, PaddleOCR, a powerful toolkit that turns any image or PDF document into structured data for your AI applications. It's an incredibly lightweight yet comprehensive OCR system that supports over 100 languages, making it the perfect bridge between unstructured real-world documents and large language models. What happens when you feed a scanned PDF report to an AI? It just sees a picture, not information. This gap between the visual world of documents and the structured data that language models need is a huge bottleneck for modern AI. But one open source project is quietly building that bridge with industrial-grade strength. That project is PaddleOCR from the PaddlePaddle team. It's a powerful toolkit built to turn any image or PDF into structured, machine-readable data, and its popularity is undeniable. It has already collected over 80,000 stars on GitHub, with hundreds more added every day. With more than 10,000 forks, it's clear that developers are adopting it in droves. And there's a good reason why. It solves a difficult, universal problem with production-ready quality, supporting over 100 languages right out of the box. The core problem is that reality is messy. Business documents, academic papers, and government forms are never just clean, simple text. They're filled with tables, charts, formulas, and even multiple languages, often captured in scanned or photographed images. Before tools like PaddleOCR, developers had to rely on older OCR libraries that just couldn't handle complex layouts. The alternative was using proprietary cloud APIs, which brought high costs and privacy concerns. Either way, the output was often a chaotic block of text that needed a lot of manual cleanup. PaddleOCR's unique angle is its focus on creating LLM-ready data. It doesn't just grab the text, it actually understands and preserves the document structure. This makes it a foundational layer for today's AI applications. So, how does it work? PaddleOCR's architecture takes two main paths. The first is its classic, highly efficient text recognition pipeline called PPOCR v5. This is a two-stage process. First, it detects all the text regions on a page using an algorithm called DBNet. This algorithm is especially good at finding text in unusual shapes, like curved or tightly packed words. After the text is located, a second model, similar to CRNN, steps in to actually recognize the characters. You can think of it like a scout who precisely outlines text on a map, followed by a linguist who reads what's inside each outlined area. The second path is more advanced. It's called PaddleOCR VL, a lightweight vision language model, or VLM. A VLM combines image understanding and language processing into a single, powerful model. So instead of a two-step process, it analyzes the entire document page at once, understanding both the content and the layout. This is more like a librarian who not only reads the words, but also understands the structure of the book, identifying headings, paragraphs, and tables. This end-to-end approach allows it to accurately parse complex things like tables that span multiple pages or mathematical formulas, outputting them directly into structured formats like Markdown. In the real world, AI engineers are using PaddleOCR to build RAG systems. These are a popular way to let an AI answer questions about a specific set of documents. Engineers use PaddleOCR to parse PDF reports into clean, indexable text. Backend developers integrate it to automate invoice processing, pulling key information from receipts and forms. It's also a go-to tool for data scientists who need to convert massive archives of unstructured papers into datasets for analysis. For basic use cases, getting started is surprisingly straightforward, thanks to clear documentation and even an online demo. This accessibility means developers can quickly add powerful document intelligence into their apps, whether for enterprise automation or a mobile scanning tool. So, what are developers saying? The community feedback is overwhelmingly positive. Developers praise its high accuracy on messy, real-world documents, especially when dealing with multiple languages. It's often recommended as the top choice for anyone needing a self-hosted OCR solution. On the other hand, some users report a steep learning curve when it comes to advanced customization and fine-tuning. Others mention that the installation can be tricky because of complex dependencies. And, as you might expect, its powerful models can be more resource-intensive than some of the simpler alternatives out there. But if we look at this objectively, the project's greatest strength is also its biggest challenge. Supporting both a classic OCR pipeline and a cutting-edge VLM across all sorts of hardware backends creates a massive maintenance burden. The project's deep roots in the PaddlePaddle ecosystem are powerful, but they can be a hurdle for developers who aren't already invested in that framework. And while the rapid pace of model updates is great for performance, it introduces a potential risk for production systems that need stability. Teams that integrate PaddleOCR deeply have to stay constantly vigilant. In the end, PaddleOCR does an incredible job of bridging the gap between raw documents and intelligent systems. It successfully balances state-of-the-art accuracy with real-world deployability. As AI becomes more and more reliant on high-quality knowledge, tools like this, that unlock data from unstructured sources, are no longer just helpful utilities. They are becoming the fundamental infrastructure for the future of how we process information.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.